Hello class. In this opportunity, we're going to work on problem 29.68 from the book. And in that problem, we have this configuration, this distribution of charge, and this is called a linear electric quadrupole. And this is the charge here. So we have two charges, two positive charges separated by a distance s from the origin. And then we have a negative charge at the center, which has minus 2q. So you can see that the net charge of this configuration is 0 because it's plus q minus 2q plus q that gives you 0. So the question here is what is the potential at any point on the y-axis? Say here, what is the potential right there? So let's name these charges. This is 1, this is 2, and this is 3. So the potential, the total potential is the potential from charge 1 plus the potential from charge 2 plus the potential from charge 3. That's easy. So now let's write them all. So this is 1 over 4 pi epsilon naught, and then we need to put the charge here, which is q, divided by the distance from this charge to this point, right? That distance is, if this is y here, if this is y, so that distance is y plus s, y plus s, plus 1 over 4 pi epsilon naught. The potential of this charge is just V2, this is minus 2q, divided by what? Divided by the distance from this charge to this point, and that is just y, plus 1 over 4 pi epsilon naught. The distance from this point to this point is just y minus s. So you get y minus s down here and q up here. So we can simplify this a little bit and write this as 1 over 4 pi epsilon naught that is common to all the terms, and then you get 1 over y plus s plus 1 over y plus 1 over y minus s. And this is actually the solution. This is your final solution. This should be enough. From here, however, you can do some extra simplifications to write this in a more friendly way. For instance, you can go ahead and do the algebra inside these brackets. This algebra here, these are just fractions. So if you do that, and I'm just going to write the solution and I'll leave that as an exercise for you, what you get is that v is 1 over 4 pi epsilon naught, and then you would get 2s squared here on top, and there is a q here, divided by y squared minus s squared. So, and that is actually a better solution, not better, but an easier solution to read. So now let's see what happens when y is much greater than s. When I is much greater than s, then that means y squared minus s squared goes to y squared. So therefore, this quantity here goes to y cubed. So we can then write this as v is equal to q over 4 pi epsilon naught, and you get 2s squared divided by y cubed. And that is your final solution. That is the potential of a quadrupole at a point on the y-axis which is far away from the quadrupole. So there is a definition that we can add here, so we can write define the quantity q as 2s squared q, and with that definition then this potential can be rewritten as q over 4 pi epsilon naught y cubed, and that is the final result here. Thank you.